Imagine a world where everything you know about reality is turned upside down, where the very fabric of existence flickers between certainty and possibility, and where your role as an observer can change the course of events. This is the mind-bending world of the Double-Slit Experiment, an experiment that challenges our understanding of the universe and asks, does reality exist as we think it does? In the early 19th century, Thomas Young conducted a seemingly simple experiment that would forever alter our perception of reality. He took a beam of light and aimed it at a barrier with two slits. On the other side, a screen was set to catch the light. Intuitively, one might expect the light to pass through the slits and form two distinct beams on the screen. But what appeared instead was a pattern of light and dark bands, a signature of interference, a phenomenon characteristic of waves, not particles. This discovery was the first hint at the mysterious wave-particle duality, a cornerstone of quantum mechanics. It suggested that light, and ultimately all matter, could behave as both waves and particles. But the mystery deepened when scientists fired individual particles like electrons at the slits. Surprisingly, even single particles formed the same interference pattern, indicating that each particle was somehow interfering with itself, traversing both slits simultaneously in a superposition of possibilities. It was as if each particle existed in a realm of potential, only solidifying into a definite state upon observation. And here is where the plot thickens. When detectors were placed at the slits to observe which path a particle took, the interference pattern vanished. The particles behaved as if they were aware of being watched, choosing one path over the other and forming two distinct bands on the screen. This phenomenon, known as the observer effect, is one of the most unsettling revelations of quantum mechanics. It suggests that the act of measurement collapses a particle's wave function, forcing it to choose a definite state. But what does this mean for our understanding of reality? Are particles aware? Does consciousness play a role in shaping the universe? Some physicists propose that it's not consciousness, but rather information that dictates the outcome. The presence of a detector, regardless of human awareness, is enough to change the result. This twist introduces the idea that the universe operates on the principles of information, like a vast computational system where data and algorithms govern the unfolding of reality. This perspective invites us to consider reality as a kind of computation, where everything is interconnected in a web of information. In this framework, parallel universes may exist, where every possibility is played out. Each decision, each observation, branches into a new reality, constantly recalculating and redefining the cosmos. As we delve deeper into this quantum enigma, we are compelled to question the very nature of existence. Is reality a solid construct or a fluid mosaic of probabilities? If particles can exist in multiple states until observed, what implications does this have for our perception of time and space? The double-slit experiment forces us to confront these existential questions. It challenges us to rethink what we know about the world, suggesting that what we perceive as solid and real may be nothing more than a shadow of a higher, more complex reality. A reality that dances on the edge of our understanding, shaped by the interplay of observation and information. As we stand on the brink of this quantum frontier, we are reminded of the profound mystery of existence. We are part of a universe that is more interconnected and stranger than we ever imagined. A universe where every observation, every thought, might ripple through the fabric of reality, altering the course of events in ways we are only beginning to comprehend. So, what is reality? Is it a fixed, immutable construct or an ever-evolving tapestry of quantum possibilities? As we ponder these questions, we are left with the humbling realization that, in the grand scheme of things, we are both the observers and the observed, integral threads in the cosmic web of life. In the quiet moments of reflection, When we gaze at the stars or ponder the mysteries of the quantum world, we are reminded of the beauty and complexity of the universe. A universe that beckons us to explore, to question, and to wonder. And in our quest for understanding, we are compelled to ask, what is the true nature of reality?